All right, so let's look at part A and review how to add fractions from way back when in elementary school. So if you had two fractions, what was the rule before we dove into adding fractions? Common denominators. Very good. So always before combining fractions, you need to make sure that you find a common denominator. So currently, our denominators 3 and 4 are not common. Okay, common meaning the same. In order to add fractions, we must have identical denominator values. So we have a 2/3, and we need to add a 1/4 to it. 3 and 4 are distinct. So what is the lowest common multiple for 3 and 4? Yes, sir?
12.
12. So what do I need to do to this fraction to obtain a 12 denominator?
That would be 4 over 4.
Good. Yep. So multiply by 4 over 4, or times 4. How about the other fraction?
3 over 3.
Mm-hmm. All right, so in so doing, you can then multiply numerators and denominators. And what is our first fraction going to be? 8 over 12. And our next fraction? All right, so the goal was to get common denominators, and now our denominators are the same. So that gives us the green light to combine our fractions. When you combine fractions, you are either adding or subtracting the numbers that are upstairs in the numerator. Okay? So in this case, ours is addition. So 8 plus 3 combines to a 11, and the 12 carries over. Okay? Please do not do 12 plus 12. All right? Your denominator, common denominator was 12. Your final answer, common denominator, will be 12. All right. So if that is a good enough review, what I want you guys to recognize is the rules of adding fractions way back in elementary carry over to trig. All right? So the same application is valid with regards to adding terms that involve trig functions. You are still going to look to your denominators and make sure you make them common denominators before bringing them together as far as adding and subtracting them. So in this example, notice that part B, our denominators are not the same, right? So cosine theta is some numerical value, sine theta is some numerical value. We don't know what they are, but we just know that they're distinct, all right? And what I mean by that is if I gave you a value for theta, theta just means an angle measurement. So let's say if I said 20 degrees, and you went right now in your calculator and you typed cosine of 20 and sine of 20, you are more than likely going to get two different answers, okay? So your denominators, for the most part, are distinct. So because they are distinct, as 3 and 4 were distinct in part A, we need to find common denominators, okay? So the way you're going to do that is, I'm going to put an equal sign here, 1 over cosine theta. What I'm going to do is multiply top and bottom, my numerator and my denominator, by the denominator value of this side, sine theta. So I'm going to multiply top and bottom by sine of theta. Okay? Similarly as what we did in part A. Okay? Let me show part A, show you how we're doing it. So we're just mimicking the same approach. All right? And then plus, I'm going to write down my fraction that involves trig functions, 1 over sine theta. But the method of approach mimics that of elementary school. All right? So don't let the trig terms dissuade you from doing what you always have been doing in finding common denominators. Okay. So nothing out of the ordinary from what we did. So instead of saying multiply top and bottom by 4, multiply top and bottom by 3, you're multiplying top and bottom by trig functions, okay? So when you glance at your denominator values, just like we did with 12, these two values are identical. Now, the order is different, but when it's multiplication, that's okay. Okay? What's 2 times 3? 6. What's 3 times 2? 6. Oh, when it's commutative over multiplication, the answer is still going to be the same. 2 times 3 and 3 times 2 is 6. So it does not matter the order. Those are still identical. Now that only pertains to multiplication, not addition and subtraction, okay? Well, yes, and addition, sorry, not subtraction. Okay, so now that they're the same, we're going to do just like we did over here, combine our numerators. So our numerator is this 1 over sine plus 1 over cosine. So I'm kind of doing exactly what I did over here just to show you guys the pattern of how nothing is changing, okay? It just looks different. What is 1 times sine theta? Sine theta plus, I bring that down, what's 1 times cosine theta? Cosine theta. And then I'm going to put it over the common denominator. It doesn't matter which one you choose. I'm just going to choose the first one. If you decided to write it over sine theta, cosine theta, that's totally fine. And here's where you will stop, because there's nothing in our chart that will help us simplify this any further. And you cannot add sine and cosines. Those are not like terms. So you stop. You can only multiply sine and cosines with one another. All right. So are we okay with this problem? Not a problem. Okay. Let us go to, let's go to part E. I'm going to skip C and D for a sec. No, actually, you know what? I lie. Let's go to part C. We'll go C, E, and then D. All right, so here we go. Still another example where our denominators are not the same. Okay, one side is 1 minus cosine theta, the other side is 1 plus cosine theta. You will still do the same approach. So I want you to go ahead and imitate what you did in A and B, and I will wait for you guys for about another minute or two. See how far can you get to this in this problem, and I'll tell you what the answer is. Okay, and let's see if you can arrive to the answer on your own. The final answer in part C is going to be 2 times cosecant squared theta. I'll write the answer right here. 2 cosecant squared theta. So see if you can arrive to this answer on your own by following what you did in part A and part B. All right, so take about 2 minutes to do that, or 3 minutes, whatever. Okay, so imitating like we did earlier, so we are going to multiply our distinct denominators by each other, top and bottom, all right? So let's put an equal sign here showing our transition. So we're going to write the first fraction, 1 over 1 minus cosine theta, just as you see it. And I know I'm going to multiply top and bottom by the denominator of the other side, right? So the denominator on the other side was 1 plus cosine theta. So 1 plus cosine theta and 1 plus cosine theta. Okay. So far, are you with me? All right. And then I'm going to write the next fraction plus 1 over 1 plus cosine theta. And I'm going to multiply top and bottom by what?
1 minus cosine theta.
Mm-hmm. So when you have unlike denominators in trig, okay, find the lowest common multiple, and usually what you're doing is just multiplying your denominators by the other denominator. Okay, there was nothing we could have broke this down out, so that's what you're doing. Okay, so now we look to verify, yep, this here denominator looks just like this here denominator. The orders are switched around, but it's multiplication, so we're okay. All right, so 1 minus cosine theta, 1 minus cosine theta, 1 plus cosine, so it's a go. So once those denominators are the same, all you're doing is taking all the numerator and you are putting it all together. Okay. Now the great thing is 1 times anything is just going to be itself, right? So 1 times this whole thing is just going to be this whole thing. So 1 plus cosine theta. So no difficult arithmetic that we need to do. Plus 1 times this, well, if I distribute 1 to 1 and 1 to cosine, it's still just going to be that. So 1 minus cosine theta. And then I draw my big line and put the 2 denominators here at the bottom. Now, because they look so alike, what I'm going to do is I'm going to put parentheses around them to keep them separated. Okay, and to show that I'm multiplying them, because multiplication is equivalent to parentheses side by side. Okay, and again, it does not matter the order that you write these in. So if you wrote 1 plus here and 1 minus here, that's fine. Okay, so up to there, is everybody okay by taking the 2 fractions and condensing? Everybody good? Yeah? Okay. What do we see here? 1 and a 1 makes a what? 2. And what's a positive cosine theta plus a negative cosine theta?
0.
They cancel out to 0. Very good. So that and that becomes 0. And what's 1 minus cosine times 1 plus cosine? Look at your difference of squares formula. Go back to day 2 at the top of your page of your notes. What was the you're going backwards. A plus B times A minus B is what? It was day 2, right? I think. Here, I'll flip with you. It was, yep, day 2, the top. So you guys have 1 plus cosine times 1 minus cosine. So how would you write it like this? So let's write this formula over here. You're close? Yes. I'm going to write this up here. A squared minus B squared is the same thing as A plus B times A minus B, right? So whatever this is, you will square it. Whatever this is, you'll square it. So if you come down here, this is your A minus B, A plus B. So what would I write? What's this squared? Just 1. Then I put a minus. And what is this squared? Cosine squared theta. Okay. If that confuses you guys, don't forget that all you're doing is multiplying, but I'm trying to save you guys on time. If I do this times this, it's 1. This times this is plus cosine theta. This times this is minus cosine theta. This times this is minus cosine squared theta. These two become 0, so it's 1 minus cosine squared theta. That's that. But if you guys know the rule, you don't have to do all that work. Do y'all understand? Okay? That's a lot of... It's a lot of math for something. If you just know the formula, you're good. Okay? All right, what is 1 minus cosine squared theta? Good. 2 over sine squared theta. So look at your formulas, and you'll notice that's one of your Pythagorean identities. So 2 over sine squared theta. Now we know something over sine is what? 1 over sine is what? Cosecant. Good. So 2 over sine squared theta is the final answer to cosecant squared theta. And you're done. Okay? Because if you hide the 2, that's like saying 1 over sine squared, right? So 1 over sine squared is cosecant squared, and then you just bring the 2 over. Okay? Y'all see it? Yep. All right, second to last one. Let's do E, and then we'll go to D. Let's go to E. All righty. Can we break? Oh yeah, sorry. Restroom? Yeah, go ahead.
No.
So E is a fraction that can be broken down, correct? All right, so break it down. Tangent. What's that going to be? Very good. So tangent is, if you look on your chart, it's going to be sine theta over cosine theta. And then cotangent theta is going to be what? 1 over, look for another one. Okay, so like on this one, you saw, Melanie, that this sine tangent is sine over cosine. Cotangent is the reciprocal of tan, so you just do cosine over sine. Does that ring a bell? Okay. 99% of the time, always use this one. Every once in a while, you'll end up using the 1 over cotangent theta. You could stand by on that, because I'm going to show you another example, because another student did it your way, the way you thought. I'll finish this one, then I'll do it the way you did. So stand by on that question, because that's a very good question. All right, so plus 1. Is everybody good up to here so far? Okay. What scenario is this when you have this over this? Very good. Keep the first fraction, multiply by the reciprocal. All right, so for those of you that have been doing the keep, change, flip, reminder of the practice of multiplying by the reciprocal. And then let's not forget our plus 1. Okay. All right, so are we able to cancel through multiplication here? Okay, no. So what's sine times sine?
Sine squared.
Sine squared. How about cosine times cosine?
Cosine
Okay.
squared. 2
Okay.
tan.
Say that again.
Is it 2 tan squared?
What is this?
Tan, but times 2.
Yes. So tan squared theta plus the 1. Is that what you meant? Yeah? Okay. So sine over cosine is tangent. So sine squared over cosine squared is tangent squared. All right, do we stop here? Nope, correct. That's a Pythagorean identity, isn't it? What is tan squared plus 1 equal to? Secant squared theta is correct. Okay. So anytime you see these plus 1s and the minus 1s, you know, with a perfect squared term, look out to see if there are any Pythagorean identities. Okay. Alrighty. Last one. Any questions thus far? We're good. Wait. In your Pythagorean identities section, right in your formula chart, this one right here. Gosh, Zach. No, just kidding. Now, here was a question. This was asked, why not use, if I can go back to the page, I lost myself. Oh my goodness, I can't find where we are. Okay. Okay, so here was a great question. So this was saying why not change, what was it? Oh yeah. So this tangent right here, he was changing it to 1 over cotangent instead. And why not use 1 over cotangent versus the sine over cosine? So know that that is also a totally different option. So if I change tangent to 1 over tangent, sorry, 1 over cotangent, as he said, and then over the cotangent, well, since this was 1 over cotangent, I'm just going to go ahead and keep that one as cotangent and put the plus 1. And now you have a keep, change, flip right here going on, right? So now you go keep this part, so keep 1 over cotangent theta, change, and then how do you write the reciprocal of cotangent?
Cotangent over 1.
Well, right now it is cotangent over 1,
Oh, over cotangent.
right? So you're going to flip it to 1 over cotangent. Well, what's 1 times 1?
1.
1. What's cotangent times cotangent?
Cotangent squared.
Good.
And then,
And then what is 1 over cotangent squared?
um, one of the cotangent is tan.
Good. So what's 1 over cotangent squared?
Tan squared.
Tan squared. And notice he ends up arriving just where we were right here, right? So still gives us the same answer. Okay. So know that there are different methods you can use sometimes. So good observation. Okay. I just tell students, because students tend to prefer sine and cosine more, to break it down. They find it easier than the identities they're not familiar with, but it's totally possible. Okay. All right. Ready for the last problem? Yep. Now your brains are tired at this point. Okay, so here we have tan minus secant squared tangent over theta. I mean tangent over theta. Secant squared theta over tangent theta. When you guys are getting ready to add and subtract fractions, if one of them is not a fraction, how do I convert that into a fraction? Very good. So tangent theta is the same thing as saying tangent theta over 1. So again, just like we've been doing all along, get common denominators. We have 2 distinct denominators, so you will multiply them by the other denominator in the other fraction. So you have tangent theta over 1, and you're going to multiply top and bottom by what?
Tangent.
Tangents, correct.
Why can't we just, cancel them, because tangents on the top and tangents also on the bottom, and get secant squared theta out of that?
Yes, good question. Can't cancel over subtraction or addition. Good question. So, great question. Why can we not just do that? If that was a multiplication, you've got the green light. Okay, does that help? Okay. And then we're going to do the same thing on the other side. So minus secant squared theta over tangent theta. What are we going to multiply this by? 1, right? Okay, so now that we have the denominators being the same, we can bring them all together. So I'm taking everything here at the top, and except, unlike the other ones, this one now is a subtraction one, but still the process is the same. What's a tangent times a tangent? Tan squared, correct. And what's a secant squared theta times a 1? Over, and then 1. Oh, 1 times tangent theta is just tangent theta, so let's just write tan theta. Okay. Okay, so here is where we are almost going to finish. So when you guys are adding and subtracting squares of trig, y'all know to go to your formulas, right? So we need a tangent squared theta minus a secant squared theta, right? So if we go to our formulas, right, we come across the fact that our second to last row, let me erase my little chicken scratch here. My second to last row right here has all the tangents in the secant. So I know I need to just zone in that section, right? But it just so happens that none of those says what I need it to say. I need it to say tangent squared minus secant squared theta. So it's tangent squared theta minus secant squared theta. But when I come over here and I look at those right there, I have 1 plus tangent squared theta, I have secant squared theta minus 1, and I have 1 minus secant squared theta. So you guys need to manipulate one of those formulas to get what you want. Which one should you manipulate to get tangent squared theta minus secant squared theta? Go ahead, Zach. Which one's easier to get?
Oh, yeah, because then you can do, I forget what it's called, but you can subtract secant squared. And tan minus secant squared minus equals minus 1.
Very good. So what you're doing is called solving. We wanted tangent squared minus secant squared. So just like Zach said, if you take this secant squared and move it over to the left-hand side of the equal sign, it will end up being tangent squared theta minus secant squared theta equals what stayed on the other side? A -1. And isn't that what we needed? All right, so let's go back to our problem to wrap this up. So tangent squared theta minus secant squared theta is -1 over tangent theta. Okay. And so make a note here to yourself just in case you forget. Pythagorean identity, you could say you manipulated it. So, okay. So when you go back to your chart, just in case you wonder, look back at this and you're like, where did I get that -1 from? All right, do I stop at -1 over tan theta?
No.
No?
Maybe negative cotangent.
Very good. So if I just hide that -1, 1 over tangent is cotangent theta. But then when I unhide the 1, I need to bring it along. So negative cotangent theta is your answer. Okay. Any questions? Yes. So when you flip over, you'll see your practice homework. I'm going to give you the answers to 1 and 2 at the top so that you know that you did it correctly, but then just know that the 3 through 8 is just the regular verification. I've given you the answer. You just ignore one side and simplify. But for number 1, the answer here is going to be a 1. And the answer for number 2 here is going to be cotangent theta. So just do the work to end up with those answers. And then like in problems number 3, you ignore one side and you work on the other side, and that's what you're going to do. Okay. All right, my dears, that's it. The rest of the time is yours.